Welcome, Christian. Hello, everybody. We're now recording. And the first thing I'd like to talk to you about is this lesson does not appear to be a match with the book. Remember how lesson 1.4 was about fitting models to data, and I mentioned to you that that was really not a part of our course. So what I did is I plugged in something that needs to be reviewed in pre-calculus, and it's the trigonometry. So we'd like to spend some time with trig review. First of all, hope all of you had a good weekend. I know I could get really used to having Monday off all the time. Did anyone have any questions from previous sessions or anything you'd like to talk about? By the way, a number of you, I muted myself. The reason is I'm picking up all kinds of miscellaneous dorm sounds and that type of thing. So that doesn't mean I don't want you to speak. If you want to speak, just go to the top and unmute yourself and please ask away. Well, okay. So our lesson today is we would like to go back and review basic principles of trigonometry, and of course, what I think generally takes about 10 days at a minimum, we're going to do in about 50 minutes. So it should be pretty quick. So here we go. Trigonometry of important angles. So we're going to develop a chart that looks like this. We're going to do it off to the side here, so I want to develop it live with you. The idea is we would like to get all 6 trig functions for all the angles that you see on the screen here. And I'm pretty sure all of you know how to do this, but this is so important, it's going to come up repeatedly in this class. So it's pretty big deal. This trigonometry is based on actually 2 very important theorems in geometry. One of them has to deal with the isosceles right triangle, where 2 legs of the triangle are equal, and what that create, and if they're equal, so we could call them any number we want, but just for ease here, we're going to call each one of the equal sides 1. Then doing a little Pythagorean theorem, we can certainly see that the hypotenuse of this right triangle is square root of 2. Okay, and the other triangle that we're going to take a look at refers to a theorem a lot of people don't remember. Hi, welcome, Jessica. Glad to have you. Another theorem in geometry is the kind of an obscure one. It says that in a right triangle, the side opposite a 30-degree angle is 1/2 the hypotenuse. So for that one, we're going to make a sketch. This time, over here in the isosceles right triangle, we know that those 2 angles have to be 45. Here, we have a 60, a 30 degree angle. So in a right triangle, the side opposite the 30-degree angle is 1/2 the hypotenuse. So in its simplest form, if we call the hypotenuse 2, the side opposite the 30-degree angle would be 1. All right. Now, with that in mind, what does that leave our last side for to be? So we'll just call that a squared plus 1 squared equals 2 squared. A squared plus 1 equals 4. A squared equals 3. And that leg turns out to be the square root of 3. So these two triangles are the key to filling out about 85% of the chart that we're going to be filling out below that. You probably know this, so just interrupt if you don't, if anything seems unclear. Okay, so then there's the basic what? The basic idea of what is sine, cosine, and tangent. And by the way, you see there's a line drawn under tan. We're going to leave those bottom three for a little bit later. So sine, cosine, and tangent. You've got that memory work, what? Sine equals leg opposite over hypotenuse. Cosine equals leg adjacent over hypotenuse. And tangent equals leg opposite over leg adjacent. So hopefully you all remember that. What is that? Like SOHCAHTOA? Probably memorize that. So with that in mind, let's get, we have one more thing to look at, and that is behavior charts. So let me explain what I mean by that. We're going to come over here and we're going to look at some unit circles. And first of all, let me change to a different color here. So let's take a look at the sine function. In a unit circle, when you draw a triangle that is in the first quadrant, you're going to get a right triangle. It looks something like this. This is the actual angle right here. And you know that sine is leg opposite over hypotenuse. Well, what is hypotenuse? Because this is a unit circle, the hypotenuse is 1. So whatever this leg opposite is here, it's going to be divided by 1. So think of it, as you've got this angle in the first quadrant, and as you move, you know, from right to left, you're going to be going in a counterclockwise motion. That sine, that leg opposite, is going to be getting bigger. So in the first quadrant, it's increasing. And because it's above the x-axis, it certainly is positive. Second quadrant. So now we sneak over here. And now that sine is gradually getting tinier, and it eventually winds up back flat down to 0 here, which is where it started off at. It's still positive, but because it's getting smaller, it's decreasing in this quadrant. Now in this quadrant, this angle, it creates this vertical side here is negative because it's underneath. So it's negative, and because it's getting negatively larger, it is decreasing. It comes down to bottom down here. Oh, and I forgot to tell you, up here it's at its maximum height of 1. Here it's going to be at its lowest, -1, and then it's still negative, but it's increasing, coming back up to 0. So sometimes I call it a behavior chart. Let's take a look at cosine next. Cosine is leg adjacent over hypotenuse. So when you look at this, just a little bit fatter. So when you look at the cosine function, now when you draw these triangles in the first quadrant, it's the horizontal coordinate, and it's full height at 0 degrees. It's full width. And as this gets bigger, as the angle gets bigger, the cosine gets shorter. So it's decreasing. Excuse me. I picked up a nice cold. decreasing, and it's because it's in the first quadrant, it's to the right, it's positive. We get over here and the cosine has shrunk to nothing. And we get over here, the cosine now moves to the left, so it's negative. And it's going to get all the way over to -1, so it's decreasing. And then from -1, it's going to come back to 0 again, so it's increasing, even though it's still negative. And from 0, it goes back up to 1. Now we're going to be in the positive, and we're going to be increasing. Notice with these two functions, 2 quadrants are positive, 2 are negative, 2 are increasing, and 2 are decreasing. That same was true with the sine. 2 quadrants are positive, 2 are negative, 2 are decreasing, 2 are increasing. And they're not in the same place, but there's 2 of each. That's not what happens with the tangent. So let's just take a look at the tangent. So for the tangent line, we need to, you remember your geometry days, what's a tangent line? It's a line that intersects a circle in just one point and is perpendicular to its to the line, to the radius at its that point of tangency. So okay, we're going to need that line because now when we draw an acute angle in the first quadrant, we're going to come out until it meets the tangent line. So that triangle is partly outside of the unit circle now. And the tangent is this value right there. That's the tangent. So it's how much of that external line have we cut off. So when it's down at 0 degrees, there's no height at all. And an odd thing happened. I mean, it's getting bigger. You know, as this comes up, the tangent line is getting quite a bit bigger. So it's increasing. And because it's up, it's positive. And when you get to 90 degrees, this crazy line doesn't intersect the tangent line. It's parallel to it. So we get an undefined value. As you come over into the negative, you got a triangle over here. Now we've got an obtuse angle. And when you have to back that hypotenuse up, and this then becomes the tangent. So you can see in the second quadrant, tangent becomes negative, and it's getting bigger because it's getting negatively smaller. So increasing, negative. Comes down here, we're back to 0 again because it flattens out, and when you back it up, it hits the tangent line at 0. And when you're down here, we're going to have positive because when you draw a triangle down here and you back it up, it hits the tangent line above, and end result is this type of thing. That's not true. That's supposed to be a negative. Let me erase. It's going to be negative in the fourth quadrant because when you draw an angle over here, you back it up, it's going to hit below the line, so it's negative. Now here's the odd thing about the tangent. Notice we have two positives and 2 negatives, but you notice it's increasing in every single quadrant. So tangent is a weird creature. It's always increasing, and yet it repeats because it's got these 2 vanishing points, so to speak. At 90 and 270, it's just like off the map. You can't calculate. It's undefined. So anyway, that's kind of we're going to be talking about behavior charts as we start filling this out. Okay, and we're going to keep this. We're going to keep our 2 geometry triangles visible as we start writing these out. See if I can write small enough for this to work. Okay, so here we go. The sine of 0. So sine is all the way down. Remember, that's the vertical coordinate, so it's going to be 0. 30 degrees. Now you can see that from above. The sine of 30, opposite over hypotenuse, 1/2. 45 degrees. Now we're in this triangle on the left here. Opposite over hypotenuse. And by the way, a comment. You may have learned from your previous pre-calc teacher that instead of leaving that as 1 over square root 2, you would rationalize that and make that square root of 2 over 2. That's fine. But I like to leave it this way because it shows right in the triangle what side is over what side. So, but you can write it as square root of 2 over 2. 60 degrees, back to the triangle on the right. The sine of that is opposite over hypotenuse. Sine of 90, we're all the way up to the top. It's full height, 1. All right, 120. So hopefully you're thinking, I can't show these all at the same time, but we're here on the sine chart right now, and we're over in the second quadrant. In the second quadrant, you can see it's starting to decrease. And sure enough, what do we use for reference angles? Sorry, I'm making you guys dizzy with me dragging this stuff, but let me get rid of that garbage I wrote. Okay. So at 120, it's decreasing, and it really, what's the closest x-axis to 120? 180. So what's the angle? 60. The same value we had before, and it's still positive because sine is above. We're up above the x-axis. 135, closest x-axis is 45 away. The sine of 45, 1 over the square root of 2, just like it was earlier. 150 is really just a 30 degrees from the x-axis, so we're back to 1/2. 180, we're flat. Again, the sine has no height, 0. Okay, now we go into third quadrant. 210 is a 30-degree angle, so the number is 1/2, as you can see when you look back over here. But because we're in the third quadrant, negative. 225, that's a 45-degree angle. All negatives in the third quadrant. 240, that's really what? 60 degrees past the x-axis. So that would be square root 3 over 2. Somebody trying to talk? Is somebody trying to communicate with me? I guess not. Okay. So that's square root 3 over 2, and it's negative. And 270, now we're stretched all the way to the bottom. It's full height down, -1. 300. So we're in the fourth quadrant. That's 60 degrees from the x-axis. So look at your 60-degree angle, square root of 3 over 2. Again, we're down, so it's got to be negative. That's a 2 down there. This gets a little bit sloppy because it's kind of tiny, and I'll go back and neaten that up. Okay, 315, 45 degrees from 360. So it's 1 over the square root of 2. And that's negative. And 330, we're 30 degrees, so that's 1/2. We're down, so again, it's negative. And lastly, 360, we're back to 0. And the sine of 0 is 0. Okay, cosine. So cosine's a left-right guy, right? It's the leg adjacent over the hypotenuse. So when we're on the two quadrants on the right, 1 and 4, those are going to be positives. And when we're on the left, quadrants 2 and 3, we're going to have negatives. All right, cosine of 0 degrees, well, that's full to the right, so that's going to be a 1. cosine of 30. So square root of 3 over 2. Got to erase that line there. Okay, 45 degrees is identical to the sine, 1 over the square root of 2. I'm going to make this a little bit bigger. I can write a little bit better. Okay. Cosine of 60. Cosine of 60. So we've got 1/2. And we're still all in the first quadrant, so everything's positive. And as soon as you get up to 90 degrees, the horizontal coordinate has shrunk to 0. 120. 120 is 60 degrees from the x-axis, so we have 1/2. Can't get rid of that. 1/2, but because it's in the second quadrant, it's negative. So this is negative 1/2. 135 is 45 degrees from the x-axis, so it's 1 over the square root of 2. Again, because we're in the second quadrant, the cosines are all going to be negative. 150 is 30 degrees, and 30 degrees is square root of 3 over 2. Again, neg. And 180, we're all the way to the left, so we're full width left. -1, stretched out. 210. That's a, what? 30 degrees past the x-axis. Sine of 30, cosine of 30, square root of 3 over 2. Because we're still left in the third quadrant, that's a negative. 225, 45 degrees. 1 over square root of 2. Negative. 240. Now we're 60 degrees past the x-axis. 1/2. Because we're left, negative. And finally, 270, cosine is shrunk to nothing again. So we have a 0. Picked up some garbage down here on the bottom, so I'm going to do a little cleaning of the slate here. All right. So, continuing. Move this over a little bit. So 300 degrees is 60 degrees from the x-axis, and 60 degrees, if we're doing the cosine of 60, it's 1/2. And because we're in the fourth quadrant, it's now positive. 315 is 45 degree angle. Cosine 1 over square root of 2. Positive. 330 is a 30 degree angle. Cosine of 30, square root 3 over 2. Positive. And finally 360 all the way full to the right. 1. Hopefully you can read that and, let me know. I've got a lot of stuff I'm writing here and I might slip up on a sign or something. Let me speak up. Okay, now we're going to do the tangent. Now the tangent, remember, is this weird guy. That is positive when it's in the first and the third quadrant. It disappears when it hits the y-axis, and it's, so let's try to keep that in mind as we fill this line out. All right, here we go. Tangent of 0 degrees. Well, there's no triangle above the x-axis at that point, so that's got to be 0. 30 degrees. Okay, tangent of 30. Let's bring this down so we can see our triangles a little bit. Tangent of 30, opposite over adjacent, 1 over the square root of 3. positive. 45 degrees, tangent, opposite over adjacent, tangent of 60. Tangent of 60, square root of 3 over 1. And the tangent of 90, there's our first undefined. I'm going to just use UND for that. 120 is a 60-degree angle because that's from 120. The quickest way to get to the x-axis is to go to 180. That's 60, tangent of 60. But because we're in the second quadrant, remember you have to back it up and you're going to have a negative. 135 is 45. That's a 1, but because it's in the second quadrant, negative. 150 is a 30-degree angle. So that's 1 over the square root of 3. And because it's to the left, because it's in the second quadrant, it's got to be negative. And 180, finally, it's flatlined again, so we're back to 0. 210, 30-degree angle in the third quadrant. Because we're in the third quadrant, tangent is now positive again. And 30 degrees, 1 over the square root of 3. Tangent of 225 is 45 degrees. So tangent of that is 1. 240, 60-degree angle, square root of 3. And then 270, we're back to undefined again. Okay, move over just slightly. Tangent of 300. So 300 is 60 degrees. Tangent of 60 is square root 3. But because we're in the fourth quadrant, we are down. We're going down, so it meets below the x-axis, so it's negative. 315 is 45. Down, so negative. 330, 30-degree angle. 1 over the square root of 3. Negative. And then finally, we're back to a flat line. So we're back to 0. Okay. So now we've got this situation here. So instead of looking at our triangles, I teach this as for cosecant. By the way, do you notice how I've designed this this section here on the left? This part right here. I purposely set it up so cosecant is the reciprocal of the sine. Secant is the reciprocal. So in other words, I kept them in the same order. Sine, cosine, tangent, and then reciprocal of sine is the cosecant, reciprocal of cosine, secant, reciprocal of tangent, cotangent. So when I'm doing this line right here, I'm going to be looking at the line up here and flipping them over, okay? So what happens when you take the reciprocal of 0? Well, you can't. Undefined. Reciprocal of 1/2, 2. Reciprocal of 1 over the square root of 2, square root of 2. And so forth. That's supposed to be a 3 down there. You can't tell. Okay. Reciprocal of 1, 1. 2 over square root 3. And by the way, the reciprocal thing works even with, yeah, got to do that better. Reciprocals and don't change signs. So we can basically mimic the sign. And here we have an undefined again. I'm running out of space. Make this a little bit bigger. Sorry, a little bit technical difficulties here. Okay, so reciprocal of 0. Defined. UND. Reciprocal of negative 1/2. That's negative. -2, negative square root 2, -2 over square root 3. Those 3's are really hard. If I make them too quickly, I get garbage. There we go. -1, -2 over square root 3, negative square root 2, -2, and undefined. Okay. So move it over so we can see what we're doing here. Now we're doing secant, so we're going to be doing the reciprocal of the cosine. Okay, so 1, 2 over square root 3. 3. Square root 2. 2. Can't take the reciprocal of 0. I see I'm running out of space here and I'm getting unlined up. That's a -1. Here we have -2 over square root 3. Sorry, this is a little bit, I'm going to have to make this bigger. It's getting a little too hard to fit everything in here. Okay. Negative square root of 2. -2. Undefined. Shift over.
Yeah, Rick.
Hello, comment? Sounded like a yoo-hoo. Okay. Cotangent, the reciprocal of the tangent. Sorry, this is sloppier than I wanted it to be, but anyway, here we go. So the reciprocal of 0, we can't do it again. Square root 3. 1 over square root 3. Now, the reciprocal of a UND is not a 0, but you can do these reciprocals both ways. The tangent is the reciprocal of the cotangent, and the cotangent is the reciprocal of the tangent. No, I can't take the reciprocal of an undefined, but the reciprocal of 0 is undefined, so they always get matched up. -1, negative square root 3, undefined, square root, whoa. Okay, where are we? Square root 3. Reciprocal of 1, reciprocal of square root of 3. Pick it up and move over. Okay, reciprocal of undefined. It's not 0, but as our try getting rid of that. Interesting how that automatically turned to a quote box. Okay. Wow, I'm getting automatic characters here that I did not intend. Like, look at that thing. That's supposed to be negative square root of 3 over 2. Negative 1, negative square root 3. And finally, undefined. Sorry, it's a little bit sloppy, but anyway, reproducing that table without really any, no calculator, no technology, probably using those two special triangles is something all of you need to be able to do. Now, I know you may not have been taught that way, and so I'm one of the reasons we're going through this today is you need to have that kind of level of being able to do it manually. Okay, and so when we talk about the sine of 60 degrees as the square root of 3 over 2, that you really can come up with that because of this kind of skill. Okay. All right, now I wanted to talk about identities a little bit. Did anybody have any questions about that messy chart we just went through? Anything about that? Okay, trig identities. Now, identities are things that are identical, identities, identical, no matter what the angle. So some we've already talked about today. We know that the sine and cosine, the sine and the cosecant are reciprocals of each other. So you can either write it like I did here, sine theta equals 1 over cosecant theta, or you could do it just the opposite and say cosecant theta equals 1 over sine theta. Anyway, that's an identity. No matter what angle you use there, you should be good. Likewise, cosine is the reciprocal of the secant, and tangent is the reciprocal of the cotangent. Okay. Now, when it comes to, so notice I've put red lines there. Those are called the reciprocal identities, those three on the top there. The next three, sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And cotangent squared plus 1 equals cosecant squared are called the Pythagorean identities because they basically come from the Pythagorean theorem. We'll take a look at those in just a moment. And then the last two are called the ratio identities. Tangent is always equal to sine over cosine. Cotangent is always what? Just to flip that upside down, cosine over sine. Why flip it upside down? Because tangent and cotangent are reciprocals. So I want to show you the trig identity, the Pythagorean identities now. Okay. So let's see. I need to grab that thing. Let's see if this works. Yeah, that's good. Okay, and then I need to a couple more of those. Okay, so now I've got those. Now I need to, let's just take a look at this first one. So sine squared plus cosine squared equals 1. This was the first of the Pythagorean identities. Now, if you remember, what we were talking about earlier, the x-coordinate is the cosine. That's the horizontal value. This guy from here to here is the sine. And the hypotenuse, just by the nature of the picture in a unit circle, has to be 1. And so one leg squared. See, I lost connection, huh? There we go. So take the leg opposite, square it, plus the leg adjacent, squared, and that equals the hypotenuse squared. And there's your, so you could, why is it called a Pythagorean identity? Because it actually comes from the Pythagorean theorem. Let's take a look at another one now. Tangent squared plus 1 equals secant squared. So I'm just going to give you an idea what this looks like. So here we have, well, we need our, here we go. So now once again we have our tangent line drawing here, tangent line. And when we take an angle and we sketch it from here to here, that's the tangent. From here to here is full width, so that's 1. And I don't have time to show you, but that hypotenuse is actually the same as the secant. And again, if you use the Pythagorean theorem, one leg squared plus the leg on the bottom squared. It's supposed to be a 1 squared. I don't change it to a down arrow, equals the hypotenuse squared, and that's the second. And I won't show you the third, but basically all of those you can see it's from a right triangle, and that's why, and it's because it's a right triangle, the Pythagorean theorem can be applied, and hence those three in the middle are called Pythagorean identities. Okay. All right. Yeah, I jammed a lot in there. Hopefully that sounds fairly familiar. Oh, I want to show you where you can go look on the website. So
is 1.4 for tomorrow for homework?
No. The reason is 1.4 is not about trigonometry at all.
So do we have an assignment due tomorrow?
Well, just keep reviewing, and maybe you can look ahead because we're going to be doing 1.5. 1.5 is all about inverse functions. That's going to take a little bit more attention, so you might take a preview look at 1.5.
So is 1.3 the only thing that we have to have turned in tomorrow if you collect it?
1.3 is the last thing you had. Yeah, that's correct.
Okay.
Now, I wanted to show you on the website. So if you go on the website, and if you go down a little ways until you get to core exercises, and when you click on core exercises, I just want to show you, this is the file that opens up. So you probably had this already, as I suggested you get it on your, maybe put it on your wall or whatever. But anyway, right on the top, you see that trig, and it says trig review assignment. And if you shift and click on that, control and click on that, it'll open a WLC website. Come on. That looks like this. And it starts going through some of the same things we went through today. So those links could be helpful to you. Okay, so go into the core exercises. There's 2 links in there. So, you know, I didn't really do it justice today. I mean, when I do it, it's rushed, and I spend 10 full classes going through trigonometry. So at least what I was trying to do is show you, give you an idea of what's important and how you need to be able to navigate in trigonometry. So, I'm sorry it went kind of quickly. Do you have anything you want, any other questions that you would like to ask? Okay, then. So I will see you tomorrow, and we'll talk about inverse functions. Thank you. Appreciate your attendance.